Okay. Yeah, thank you. A warm welcome here to everyone at Bio360. My name is Markus Vagt. I'm working for the DLG Service GmbH. DLG, it's a German association for agriculture in Germany. And our company, our association stands for knowledge transfer, and we are organizing and creating platforms for agriculture, technology, and of course as well for biogas. So a warm welcome here for our next session, biogas plants in focus, innovation and key components from digester to agitation technology. And why we are here? Because we are a group, or we are represent the red one. Yes, I. So yeah, why we are here? So we are representing here at 360 together in a joint booth a group of companies dedicated to the biogas technology part, and we want to offer here in the French market, of course, our technology. So our session is well prepared from the beginning of the process, from the digester up to substrate processing technologies, and at the end of all, the really big focus on steering systems and agitating machineries. But before we will start with our first speaker, a little bit from our side as well, a presentation for our next upcoming event in Germany, our Biogas Convention and Trade Fair. It will be in December, from the 9th to 11th of December in Nuremberg. So in the south, is not so far away here from France, so you're very welcome as well to see there in Germany the whole variety of biogas technology. And I think we will switch now to the next presentation, and I will as well very welcome our speaker from Henze Harvestore, Stefan Wichelmann. I know, hi Stefan. So I know you're since many years an expert and passion for steel. So that's as well a little bit the advice, what kind of digesters we are talking about. And yeah, Stefan, the stage is yours. Feel free.
Thank you. Yes, thank you, Markus, and welcome everyone. Yes, today I would like to introduce you to our company of Henze Harvestore. Yes, Henze Harvestore is located in the western part of Germany, in Unna. We are a leading company in the sector of storage tank solution for worldwide projects. We design and construct the bolted steel tanks based on our customers' requirement, so we can build the tanks however you need them and you require them. The materials we used are animal steel plates, epoxy-coated steel plates, and also stainless steel plates. So we are very flexible in the choice of material for your tank design. Yes, here's a little history overview about our company. We were founded in 1959 by Mr. Erwin Henze. In 1978, the former company Henze Harvestore was founded. In 1985, we constructed our headquarters in Unna. The next step was the construction of a branch office in Sörbig. It's the eastern part of Germany. And after that, we extended our headquarters for another warehouse. And in 2022, Mr. Benjamin Budde became our new CEO. And today, with approximately 50 employees, we have a yearly turnover of 25 million euros. So that's some key facts about us. Yes, the markets we act in are more or less the biogas market, the agricultural market, the industry, and the municipalities. So these are the four key markets we are active in. Yeah, for the biogas market, for especially, we offer tanks like a hydrolysis tank, the buffer tanks, CSTR tanks, which are centrally steered tank reactors with one mixer from the top. We also offer digesters with a double membrane cover, secondary digesters, storage tanks, and final storages. Okay. Here you can see one of our core products. This is a CSTR tank. As I mentioned before, you have one central mixer from the top. So you only require one mixer, which is low energy efficient or very energy efficient mixing system. You have an ideal mixing ratio with a perfect working environment for the bacteria because you have a slow moving medium. Also, these tanks have the advantage as you only need a very small footprint. You don't have the big size of diameter tanks. Yeah, here you can see one of our latest references in the Netherlands, in Tilburg. We built there these 4 steel digesters, which you can see with a diameter of 21.33 meters, with a height of 20 meters, cylindrical height. As you can see, you have a net volume of approximately 7,100 cubic meters per tank. These all came together with a stainless steel roof, so you have a very resistant material against the gas on the top zone. There's another reference in Germany, in Rheine, where we built 3 of these digesters completely out of animal steel plates, also with a diameter of approximately 24 meters by 22.5, with a net volume of 9,800 cubic meter. Yeah. Here's some more references. As you can see, we can also build tanks with a double membrane cover, with a steel cover, and side entry mixers, so more or less whatever the customer requires, we can design and build. Yes, and I would like to show you a little movie how we install our tanks, so you have a better overview on how we work, so enjoy the movie.
While we are seeing this video, can you explain a little bit about the advantages or what we can see as well?
Yes, as you can see, we construct bolted steel tanks, which are built out of different or segment steel plates. Each steel plate is sealed up with a Sika sealer in between, so the tank is totally tight or watertight afterwards. And now you can see how we settle down the tank. There's also a Sika sealing underneath the bottom angle, which is connected to the foundation plate. So our tanks are built from the top to the down, so we lift it up ring by ring, and then later we settle it down to the ground. We also install all the inside holders for the heating, for example, pipe holders, the mixer flange on top of the roof, the staircase and walkways. This is all what we can do and what we offer and design. Yeah. Here again, it shows you a little bit where we are active and what we are doing. Yeah. So usually our CSTR tanks are designed in the top 1 or 2 rings in the gas zone with the stainless steel material, and the anaerobic part of the tank is used a simple enamel coated or epoxy coated steel. Okay. Yeah, that was the movie. Yep. So here's some extra markets where we work, or some different markets, as we are also active in the agricultural business. We design the slurry tanks, the gas-tight grain silos, or the CCM silos, which is a crop corn mix, what you can store in these tall, thin tanks, which you can see. Yeah, another market for us is the industry sector, where we also build bulk storage tanks, anaerobic tanks, wastewater tanks, or firefighting tanks, or whatever you require to store any liquid medium. Yeah, and last but not least, we have the municipalities, where we build, for example, the SBR tanks, thickener tanks, sludge storage tanks, mixing and equalization tanks, and also many, many more special tanks. So this is also one field where we are very active. All special requirements, what the customer has, we can usually design it also. So yeah, here you can see some references and customers where we worked with in the past. And yeah, that's about it. So thank you very much for your attention, and feel free to visit us at booth E49 afterwards.
Yeah, Stefan, do we have some questions about the technology, or maybe why steel and not concrete? I think that's what many people are thinking about. Okay, Stefan, thank you for your presentation. And as Stefan told, if there are more questions at the booth, you will find him at E49 in the middle of the hall. And our next speaker is there he is coming. Okay, perfect, he's here. BioG, Mr. Michael Weidinger. And yeah, as well, many years in the field of biogas, an upcoming really like a superstar in our business, and yeah, specialized from preparation of substrates up to feed-in technologies, and as well for gas cleaning and fuel station services. But you will explain it very well. So take the red microphone. Next time is yours. This is a presentation. Yeah.
Hello from my side. My name is Michael Weidinger. I'm from Austria and I'm Vice President of BioG GmbH. As it's already mentioned on the screen, we produce or want to produce energy out of straw and manure. What about us? Yeah, we develop and produce technical solutions for using field wastes and every material what is available for the biogas market, and to save money with the materials. Our experience, we have our own biogas plant in Austria. We produce 500 kilowatt of electricity and use just corn straw, manure, field wastes and so on. And we have built approx 350 to 400 plants all over the world. Why we want to use biogas from straw and manure? For sure there are more points than on the screen right now, but for sure it is cheaper than silage. We have no area competition to the farmers because we use the wastes and not the corn itself. No food competition, it's also for public very interesting. And we reduce climate gases and so on. We came to the conclusion what are the challenges to use field waste and straw and manure, and we came to 4 main parts which are the most important ones. It's the harvesting, the storage, the difficult one, the preparation of the material, and last but not least the biology, to have also good bacteria in the digester. For example, here's an example how we harvest the corn straw on the field. That means we use the grain for food industry, pig industry and so on. And afterwards we pick up or we shred the material on the field, pick it up, and then we can pick it up with a pickup wagon to bring it to the silage clamp. Here we have also a C&G, New Holland, where we pick it up on the field. Yeah, we, for example, store it in silos. When it's drier than 85% of dry meter, there will be also stored in bales, but normally on the silage clamp. Now to the most important thing to use these straws and materials in the biogas plant, it's the preparation itself. That means the feeding and storage technology, the shredding, or fraying, how we call it, and the liquid feeding to liquefy it with digestate and with other liquids. We build our feeding technology from 5 up to 220 cubic meter, different loading types, mostly with the telescopic loader or with conveying belts, automatic crane solution are also available, but normally with the loader. This is how our dosing container looks inside. We have a storage container with a walking floor, like on the trucks on the road. In the front we have wall augers which are discharging the material and loose it up. That means we do not press it through any hole or something like that. We discharge it and then we work with gravity in the dosing container. That means the discharging augers bring it to the dosing auger, and afterwards we drop just via gravity into the shredding system. That means no blockages, no bridge building problems due to working with gravity. Here is the most important thing, the shredder. That means when we do not shred the material, we can feed a bit amount of material into the digester, but we will get problems with floating layers, with crusts and so on. That's the reason why we want to fray it, we want to shred it to increase the surface of the material, that the bacteria has more things to bite on it, let's say. Here are some different things how you can shred the material. Normally we work with the medium phase because it's the best way concerning energy consumption and maintenance and wear costs. You can also make it fine, let's say, but there we have higher energy consumption, and let us do the work. Let the bacterial do the work. Here we have a dry feeding solution, for example with 200 cubic meter, with a shredder and the auger afterwards, which is dropping into a plug auger in the digesters. We have different solution here, just a liquid feeding system where the client do not use big amounts of fibrous materials. A liquid feeding with our biomerge. Here we have included stone trap, which is very helpful to avoid big maintenance costs on the pump afterwards. And here is the main system. That means a storage container, a shredding solution, after the shredder a mixing solution where we take liquid from the digester, mix it up in the biomerge, in a big mixing chamber, and we also put out the stones and metal parts in a stone trap, and afterwards we bring it back with the pump into the digester. Here, for example, a bypass solution when a client has small particles or small materials and long fiber materials. That means he can decide on which way he wants to feed. Last but not least, the digester biology is also a big part where most clients do, let's say, mistakes from the beginning because they normally work with corn silage and so on. But when they are working with corn straw, for sure the biology will change in the digester, and here we have also, let's say, the expertise to help the clients. One big part is that we build a system with no interface. That means we also build our switch cabinets by our own, we build our software, we do everything in-house. That means the whole system, when the client has problems, he just needs to call BioG and not any other company, not the fraying technology, not the pumping solution. He just have one person who is calling, and this is, let's say, very helpful for the client by the end of the day. The control remote and maintenance is, let's say, we have 24/7. We can take a look on the machine everywhere around the world. That means we can help the client to increase throughput, to decrease energy consumption, and what the client wants. When he has changes in the material, it will be done automatically from the software, and that's very helpful for the clients. Now I have a short video in 3D. Is it working? Yeah. That's how it looks like exactly also on the screen on the HMI of the switch cabinet for the client. That means here he sees with colors, different colors, the energy consumption of the augers, how much is in the dosing container, which throughput do I have, and everything is steered by his own, and that's how it looks exactly for the client on site. It's helpful due to that most of the time are many people working on the sites, and it's better visualized that they see it better when there are problems anywhere on the machine, and I think it's quite a good example for 3D visualization. that's how the augers work. That means nearly no time all together are running. Just when they need to run, they run. That means we avoid high energy consumption of the whole system. Good. Yeah. My last point, just to explain it to you shortly, we also produce CNG stations. That means we take biogas from the digester, we clean it, we compress it to up to 250 bars, and then we are able to fill up tractors or telescopic loaders and so on with CNG. It's a bypass solution for biogas plant, and it's very interesting, for example, for biogas plants who produce electricity in a flexible way, and the other time when they are not introducing electricity, they can produce their own CNG and work with the vehicles what are available. Yeah, with BioG from harvest to fuel, the whole circle all in a sum. Thanks.
Thank you, Michael. That was really very interesting. First, from my side, a short question. You was talking lots about the controlling units and controlling systems. Is there, we are talking about, or in the last time we are talking lots about artificial intelligence, KI. Is there as well some development to go and to participate in this market to automatize it more and more, or
a bit, let's say. For example, we are working right now on a solution where our system knows which material is in the dosing container, that we know by the end of the day when produce I my gas. That means when I have in the front corn silage, I know I have more gas. When I have in the front wet manure, I know I get less gas and I will feed more. And that's, for example, one topic where we developing ourselves at the moment.
Okay. Then from my side as well, a question due to the CNG tractor. So if you are a farmer, and I think as well here in France we have lots of farmers who need tractors to prepare the land. What's the dimension? How many tractors you can fuel with your system? Because I saw it's everything in a container. It's a container solution, so a small scale solution, no so high developed like for the industry to gas or grid feed in. Yeah.
Let's say the common system is a small bypass solution for biogas plant. That means we just take a part of the biogas to produce CNG. But right now we are also producing big upgrading station with the CNG compression. That means we are up to 2,000 cubic meter of methane are possible in that case.
So there's more possibilities to be autonomous as an agriculture. He can proceed with energy production, maybe with a heating system what he has, and can take advantage of the gas production for fuel systems.
Exactly.
How many of them? Is it a booming market, or is it present here as well? And do we have some references here in France?
It will be a booming market for mostly or most of the time in Germany due to, let's say, flexibility of the biogas plants with electricity. That means the clients will produce electricity, for example, 2,000 hours a year, and the rest they have no possibility to earn money. And therefore, they are implementing the CNG station to produce CNG. That will be a big part in the future.
Okay, I think we have a little bit more time, not so much, but one or two questions. Do we have a question here in the auditorium? This one.
Hi, my name is Lars. Thanks for the nice presentation. During your 3D video, there was a technology after the grinding before it goes inside the pump.
Could we go back to show it again?
Mixing liquid inside.
Yes,
and then there was a roller or something like this.
That's our own development. It's the BioMerge. That means there are some on the market, some mixing pumps and so on. But we increased the volume of the mixing chamber, to get more throughput and less energy consumption. We have an auger with a 700 millimeter diameter. That means we mix it to the front. We have a stone trap in the front, do it to centrifugal force of the auger, and afterwards,
yeah, there was this roller here. This one, this yellow, green one, and I just
that's the level sensor. That means the level
Alright.
sensor is swimming on the mixture, let's say, and then we always have the same level in the mixing chamber, and that means always the same mixture after the biomerge.
All right, thank you very much.
Okay, and I think with this question, is there any more question? No? So then we can proceed, and we have directly the next speaker of our small session. So thank you, Michael, that was very interesting. Yeah, come up to our stage, take the red microphone, and yeah, we are proceeding here with Tietjen Verfahrenstechnik, specialist as well for preparation of substrates, but not only shredding systems, what we saw a little bit as well for BioG, but as well for the very, very important thing like depackaging systems. So not only for agriculture, biogas production, but as well municipal waste or the food waste industry sector. So yeah, warm welcome. Where we can find you? Booth number is
F72.
F72, and your stage is yours.
Yeah, thank you very much. Thanks for the nice introduction. Hello also from my side. My name is Lars Weiss. I'm sales manager at Tietjen, and I want to explain you today how you produce biogas from difficult input substrates with using pre-treatment. And after a short intro about our company, I want to show you the types of biomasses and the challenges that are related to them, and then the three different technologies that we can offer to treat them. Yeah, starting with our company, who we are a manufacturer of hammer mills and as well separating technologies. We are located in northern Germany. We are doing this already for more than 60 years, and we're producing machines that are fulfilling the requirements for industry applications. Industry applications does mean they are having a quality to run 7 days a week, 24 hours a day, 365 days a year. We are not only machine manufacturers, we are also turnkey project providers, as shown in the picture in the middle of this slide. That is a combustion plant which was converted from coal firing to wood firing. We supplied the complete treatment of the wood, for example. The three red dots in the middle of this picture are 3 hammer mills, and all the rest is the complete handling and storing in between. So turnkey projects are also possible for us. And we are successful doing this in many different industries, as shown here on the slide. And today we are focusing on biogas and organic waste. Coming to the biomasses, we see two main types of challenging biomasses. First one is farm-based material, like here. It's very interesting for biogas plant owners because it's often cheap to get these material. Unfortunately, it often contains long fibers and also is often from poor quality. And this material then, of course, is related to some challenges listed here. Feeding problems, already mentioned, swimming layers, mixing problems, and of course, low gas yields. Yeah, and to treat all this and solve all this, solution must be very reliable, as it is essential system in the feeding line. When this stops, you always have problems in creating gas at all. It must be very flexible, as we have many different types of these materials, and it must, of course, be cost effective. Very important point. You can make it as fine as possible, but when it is too expensive, it don't pays off. So that's the focus. And the second biomass that we see, which is difficult, is organic waste. You see it on the pictures. It can come from food waste with very liquid content. It can come from municipal collected organic waste, but then it is much more dry and has different packagings. Or on the last picture you see, it can even contain more packaging than organic. And that's very challenging in treating all this heterogeneous material with one treatment solution. And that's unfortunately what the waste treatment companies need to work with every day. Yeah, critical topics here is the cleanness of the biomass after the treatment, that you fulfill all the requirements, the rules, let's say, for purity. Then the reliability is also very important, because this material cannot be stored. Once it is at the plant, you need to treat it and to feed it. Ease of maintenance is also very important, to minimize the downtimes if you have something in this material. And of course, again, cost of the treatment. Okay, and I now want to show the solutions for these two types, starting with organic waste. Perfect treated organic waste looks like this: a high dry mass, which means a high concentration of energy per cubic meter. It's completely pure, free of any impurities, and it's homogeneous and pumpable, so it can go directly to the digester. And then on the other hand, we have the separated packaging. This looks ideal like this, so free of organic content, as dry as possible, as this often goes into incineration. And our technology to achieve this is as shown in the video. It's double rotor depackaging machine with two 55 kilowatt engines, motors, with a throughput up to 25 tons per hour, completely made of stainless steel. It can be fed continuously from a completely mixed organic waste. In the bottom we have 12 millimeter screens. Mode of action is shown here: a particle size reduction in the first step, pressing the material then over the screens, so the organic is going through the screens and the packaging stays. A second rotor repeats it and then throws out all the packaging. On the side we have a dewatering screw that squeezes out remaining liquid residues, so that the material falls out as dry as possible at the end and can go to the incineration. And the organic slurries is still collected and goes into the underhopper, and there it is completely homogeneous, free of impurities, and can be pumped then into either the digester directly or a storage tank, for example. I wanted to show also a picture of the ease of maintenance. We have an hydraulic opening system of the machine. The housing is split into two parts. That's a small video that shows how you access the machine. It's tool-free, so you don't need any tools or open any screws. Everybody can just go to the machine, push two buttons with his two hands, and then you have access within, let's say, 30 seconds. If something hits the machine that don't belong there or cannot be treated, then it's very easy to remove it, and also the maintenance is very easy to do like this. And it's still confirmed, of course, with every health and safety requirements. And I must say, the customers like this very much, because they don't need to rely on Tietjen engineers that comes for maintenance. They can help themselves, and really quickly. That's a big advantage of the system. Yeah, this is a small sum up of the advantages or benefits of the system. As explained, excellent separation, high dry mass, extremely robust. We are talking here about 20 millimeter stainless steel. It's really easy to handling, and is very cost effective. You can get this as a machine only, as shown on the top, as a module like here in this middle picture, or also complete plant solutions. All is possible. And I also brought two references. This is the first one, is a relatively small plant, which we installed last year in South Germany. It contains a 25 cubic meter dosing hopper, which is not in the basement, it's on the ground, but still can be filled directly from the truck. It has also a cover on the right side where they are able to tip bins and unload bins, combined with a small pre-washing of the bins already, and then you have the screw conveyor technology in the packaging machine. And input material that they treat looks like this. Who is working in this industry knows that this is heavy material, heavy packed, with huge 1,000 liter bags inside our original packed material, and that works well. So the hopper already opens these huge bags. And on the right side you see the separated plastics. And the second reference I wanted to show is, let's say, the other end of the possibility. It's a huge plant we delivered in 2020 together with a partner in Switzerland. There the acceptance area is on one level, and the whole technology is in the basement. You see it on the right side. The hopper is in the basement, filling comes from the top. And here you see the acceptance area. It's possible to unload trucks with loose material, but also bins, and that's an automatic tipping station. In the background you see an automatic washing station. So that means bins go automatically into the washing station and then into the clean room where the truck can load the bins again. Okay, that brings us to the farm-based material, and perfectly treated material, our customers say, looks like this. It's not only shorten the fibers, it disintegrates the fibers, the material. So it needs to be, or it needs to have destroyed lignin structure, that the digestible material is available for the organic, for the bacteria. That's the important thing. Could also look like this with different materials. And our solution to achieve this is the biomass shredder. What makes this unique is the high throughput. 15 up to or more than 15 tons per hour is a goal. We designed this because we have many requests from customers that somebody should build a bigger system than the ones available on the market. And we did it at one point in 2023. We decided to do it. And of course, by designing this high throughput and this big size, we also took care about all the complaints they have about the topics of accessibility, maintenance, and also maintenance costs. And all this is included in this machine. And this is a solution for really big biogas plants. And the system works like shown on this video. So it is, again, continuously feeded. In the entrance we have a magnet separator so that iron metals cannot hit the machine. It is available in a manual opening system, but also in a fully automated system. We have a door locking with a key transfer system, so you can only access the machine when it's stopped. Inside we have a rotor with 6 beaters, and the material falls in from the top continuously. The ripping comes cut already long fibers and then transports it into the grinding area where the beaters destroy the structure between the impact area and the grinder and the beaters. The outlet is directly in the bottom of the machine. That means there is no distance between screw conveyor and beaters. That avoids bridging with sticky material, with light material. That is not a problem with this system. And afterward, it can be fed directly with the screw conveyor into the digester, but it could also go into a liquid feeding system, a biomix pump, for example. Both is possible. Regarding maintenance friendliness, we included also a crane. So if heavy parts needs to be removed, you can use this. Customers like that a lot. Then we often are asked, what's about stones? We just heard it in the presentation. This machine just grinds it. Stones are not a problem. It's a size like this. You will not find them again. It's powder afterwards. Iron metals will be separated with a magnet separator, and everything else that goes into the machine and causes a vibration or an imbalance will be recognized by a sensor, and then the machine stops. So then you can remove very large particles through the door. Yeah, here are some examples of different input materials and the different finesses. I think I go a little bit quicker about this or through this, but it shows different type of materials can be treated: cattle manure, horse manure, even wood chips, and the light miscanthus grass is possible. Here you see the effect of different frequencies of the rotor. You can adjust the fineness of the material or the fineness to be produced via the frequency converter of the grinder. It's really easy. And since the big BMS 1500 was so successful already in the last year, everybody asked that, why don't you build also a smaller version now? And that's what we decided last year. So now also a smaller version of the BMS 1500 is available, and that's suitable also for a little bit smaller biogas plants with a throughput between, let's say, 8 to 10 tons per hour. And as you can see, the installed capacity between 55 kilowatts up to 160 kilowatts is possible. And yeah, with this different sizes, we can equip almost every biogas plant, I would say. This is how they look compared to each other in reality during delivery. So you see it's a little bit smaller. Here, this is, shows a little bit that we, in the first year, already sold more than 10 different machines in different markets in Germany, but also in Asia. Yeah, and here also have a reference with me. That's a plant in Western Germany who treats 200 to 300 tons of solid manure per day. With this system, the system grinds between 15 to 20 tons per hour. That's the reality at the end. We plan for minimum 15 tons per hour and achieve 20. And if you wonder how big the mountains are of solid manure when you feed 300 tons per day, it looks like this in this picture. And very important, because also energy consumption was mentioned at the beginning already. For this system, including the dosing and the screw conveyor system, we only use around 6 kilowatt hours per tonnage to achieve this, which is really a good result, I would say. That brings us to the third solution that we have. If this is not enough, the coarse grinding before the digester, then you still can use our Impra grinder. That's the system that works in the bypass to the digester, like shown in this video. It takes out the digester egg via a pump into a hammer mill. This is completely closed with a screen. These looks like knives, but it's actually hammers inside, and they are also disintegrate the material, so they grind it, and through the screen hole size of the screens, I can define the particle size after grinding, and then I can give it back into the digester to really boost the gas yield. Gas yield boosting is the main goal here, but of course it also has a side effect of reducing the viscosity inside the digester, and also reduces the problems with steering and swimming layers. We have two sizes of this machine, Impra 3 and Impra 5. Smallest biogas plant who is using this is around 300 kilowatts, and everything, I would say, up to 1 megawatt is suitable with the Impra 3, and over 1 megawatt is with Impra 5. Yeah, the effects are up to 15% more gas, depending on technology and input that you are using with this system. Exactly, yeah, I think that's good enough. So that's a little bit of sum up. So there are really challenging materials available. They are cheap and they're interesting, but they're all related to some challenges. And there are also the machines available to make them usable in biogas plants. We are doing this for more than 60 years already, so they are proven. We are developing tailor-made solutions as plant designers. And yeah, we would be happy if you contact us if you have a question about this or have a project. Guillaume and myself, we are on our booth right over there in F72, and we're happy to discuss with you. Thank you very much.
Thank you, Lars. Perfectly in time, but we don't have so many time for questions. Maybe one question. Nothing? We heard a little bit about disintegration. That's a big focus as well on your technology, but by using mechanical power to do that.
Yeah,
do you think that that's the only way to do that?
Yeah, I think it must be a main step to really, let's say, treat the really heavy stuff. I think there, of course, are other technologies like other mechanical things, and also enzymes or special bacteria could be a solution. But I would say, as a first step for this really heavy material, there's no alternative.
Okay, thank you, Lars. And disintegration is the topic of our next session or next speaker. Please come here. Okay, thank you. So We are proceeding now with Weber Entech and Jan Talkenberger, another expert of biogas and especially for disintegration, but while ultrasonic use. And maybe there's as well some synergy behind mechanical disintegration, and maybe it's finer, or you will explain it. Okay.
Okay, hello everybody. My name is Jan. I'm with Weber Entech, which is a company focusing on ultrasound technology and bringing it into the treatment of substrates in biogas plants. We do this since 15 years in the meantime, also worldwide. And yeah, I will walk you through the technology quickly a little bit, and then at the end I have a collection of references as well. So the company was founded, like I said, 15 years ago. That's where we built the first plants in Germany, obviously. And so the background is, certainly you mentioned cavitation, but we are coming from the ultrasound field. So we were a company focused on various applications for ultrasound, and then when Entech was founded, we looked at treatment of substrates in the biogas. So what the ultrasound does, it is generating cavitation in the media. And cavitation is obviously by far the most effective mechanical disintegration technology, what we found 15 years ago as well. And so we brought the technology into the biogas plants, and in the meantime we have what you see here, quite a global presence with more than 200 plants delivered. A few of them we will see later. We not only do this in biogas, we also do this in wastewater treatment plants and a few other industries. But it's always the same principle. Ultrasound inducing cavitation in the media, and the cavitation is the mechanical force which is disintegrating the cellular structures. And the benefits are obvious. I don't need to repeat that again, what we just heard. We can increase the gas production. We make difficult material available for an enhanced degradation. Reducing viscosity will help to steer or load more solids in the digesters. All the known problems attached to that we could potentially solve. The economy consists of a few factors. Usually you can win some profit with a higher gas yield. You can also save cost for disposal. And at the end, the systems we've provided now, you have seen that more than 200 in average. We generate income which pays back for the installation within 2 to 3 years. So, physical principle, I mentioned that, based on cavitation. Microscopic scale steam implosions, millions of them in the substrate, will be disintegrating the cellular structure. It's not making a long particle short or a big particle small, which all the others are doing. We are disintegrating the cellular structure of the media with cavitation, and that's maybe the main difference here. And I skipped the ultrasound details, but maybe that's important. This is a reactor which we developed 15 years ago, and that is where we started to enter the biomass treatment field. It's a piece of pipe. The material is flowing through an ultrasound field or through a cavitation area, and then whatever is going through that will be definedly and precisely treated. Non-clogging, no wear out. It's basically a maintenance-free design, also with a very low electricity consumption. That's the real-time picture of that. Then we always build a machine. We have a number of reactors according to the volume we want to treat, a pump, a macerator, a control box. And so we provide turnkey packages to digestion plants. The implementation is rather easy. We draw from a digester, treat it, bring it back, operate 24/7 on the biogas digesters. I skipped the wastewater here. Yeah, well, known benefits, which then always add up to, of course, also a very proper business case. Now, if I have 2-3 minutes, we can jump through a few of the references. The target is not always the same. We have customers who can actually sell more of their electricity or produce more gas, but in Germany, not always the case. So we can also benefit from saving substrates. That customer was replacing the majority of his corn substrate with grass, so much more solids into the digester, but with the disintegration or with the ultrasound disintegration technology, he was able to almost replace all the corn with grass and achieve the same gas production. Then it could be also a mix. The reduction of viscosity was also mentioned before. This will help to save electricity on the agitators, or they can run the agitators just less hours a day. Typically, the savings on the agitators is overcompensating the electricity we need for the ultrasound. So the energy balance is positive, and then the other savings are net profit. We can jump through this. Average improvement ratios are around 15%, sometimes more, sometimes less. It depends a little bit how good the plant was operating before. And you just see a few pictures of what we have achieved. Let me stop here. We also build this in containerized plants when we have no room to install, or it's too difficult to make space. We just build it all in the container, ship it on site, and then we only need to connect the pipes and the electricity and push the button, and it's very easy to start up. Or another one, we find a space wherever in whatever configuration. Now in one of the tricky one here as well. Or that, or that, or that. So I could go on a little bit more with more pictures, but I think we got the message. We do this since 15 years, and I would say in the meantime, we have probably treated all the substrates which are around. Wastewater sludge, that one I skip. Yeah, we are here on D51. Anybody wants to discuss this deeper, would be looking forward to.
Thank you, Jan. That was as well very interesting. Any questions here from the auditorium? You have one? Yeah, okay.
Hi, thanks for the presentation. I think you mentioned this already during my talk. I would like to know where the limits are of the system. Where would you say it's not enough to do it with an ultrasonic system?
There are no limits. Any material which we can pump, we can treat.
So that means pumping is a limit, let's say. When it's not pumpable, we cannot treat it.
Yeah.
Okay.
You need to pump it through.
I think that's the interface then between mechanical treatment and ultrasonic.
Yeah, I think as well. It maybe I don't have a good comparison directly of the volume comparable to the energy input, but it seems that the energy input for the ultrasonic cavitation is a little bit less, I would say. So maybe there's as well as a synergy between a pre-treatment system, let's say for really straw, bigger materials or ships to shred it, to fine it, and then finally, if it's pumpable, to go through an ultrasonic system.
It's a good point you mentioned that. I think we really need to distinguish here. Disintegration is not disintegration. I always need to treat the material to be able to handle it in a digester. That's not what we do. We then come when the material is in the digester, it is already there, and then we can come and reduce the viscosity, we can crack the cell structures. That is what we then do. But you already need to disintegrate on another level to bring it into a digester to be able to pump and steer and mix. So there's two different kind of mechanical disintegration. One is to make it possible to handle it, and the other one, like we do it with the cavitation, it's also a mechanical technology, cavitation, but that is on cellular scale. It's simply a different scale. And yeah, the electricity consumption is not very high. One of our reactors has a 1.2 kilowatt electricity consumption. That's
you mentioned as well heat, the high heat, but at cellular level. So finally, that's not nothing for the substrate.
It does not affect the substrate temperature.
Okay, Jan. So that's I think we are now at the point where we have pumpable materials, and everything what's pumpable in a digester, you have as well to mix it and steer it. And yeah, warm welcome to our next speaker from Amatec, Mr. Florian Wück. Okay, gets the red one.
Now it's a little bit louder. I think they're half of the guys I know. Yes, my presentation? Yeah, okay. Thank you and welcome to my presentation. I'm Florian Wück. I work now for 14 years in the biogas market for mixing solution and pumping solution. And the company Amatec was founded in 1965, now for 60 years. And we produce steering and mixing solution for the biogas plants. Our solution is for really efficiency mixing solution in the biogas plant, because the power consumption in every biogas plant is too high, because we would like to produce electricity, not for the electricity consumption. High power consumption of the steering technology up to 75% of the self-consumption of the entire system. Is often due to the outdated steering technology and the steering times in the respective containers or tanks. Yeah, because of that, we produce an energy efficient mixer on the market for the site entry, and the flexibility of the mixer is really important too. Because of that, we make the replacement of the steering technology now on the biogas market